Dear students, welcome to the lecture series on cost accounting. Today in this lecture, we shall learn two very important techniques of inventory control. First one is known as economic order quantity and second one will be setting up of various stock levels. The objective of this lecture is to understand meaning, concept, assumptions and method of computation of economic order quantity. We shall also learn setting up of various stock levels to maintain a minimum level of inventory so that production can go on fluently. These levels are maximum level, reorder level, minimum level, average level and danger level. We shall learn its formulas as well as objectives. Now students, we will learn about economic order quantity. Economic order quantity is oldest classical production scheduling model. The basic problem comes in inventory control is what quantity of an item should be ordered and when it should be ordered. So we need to set an ideal order size. In order to set an ideal order size, we need to take into consideration two factors. These are known as ordering cost and inventory cost. Since these costs form the part of total cost of inventory, they need to be minimum. So we can say that economic order quantity is that reorder quantity at which ordering cost and carrying cost should be minimum. That means that at this ordering level, the carrying cost and inventory cost comes equal. Now students, let's learn what is ordering cost and what is carrying cost. Ordering cost means that cost which we need to incur for acquiring an input. What does that mean? It means that whatever expenses has been incurred to bring the inventory from the starting point to the factory premises or to our own organization are considered as ordering cost. Examples of ordering cost are cost of placing order, cost of transportation, cost of receiving the goods and cost of inspecting the goods. Now students, let's take an example so that this concept comes to us in a very vivid fashion. We have hired a truck so that we can carry the inventory to our organization. Suppose we need 10 microwaves for our production. So what happens that we have hired a truck, it is carrying those microwaves from the point of inception, that is from their manufacturing unit to our organization. So we need to pay certain transportation charges. So whatever higher charges or freight we have paid to the truck driver is known as ordering cost for bringing the asset or inventory to our organization. Now students, let us learn that there is an inverse relationship between order size and ordering cost. What does that mean? It means that both are running in opposite directions. The larger the order size, smaller will be ordering cost. The smaller the order size, the larger will be the ordering cost. Now let's learn this with the help of an example. We are continuing the example of microwave. Our order size, we assume that it's 10 and our requirement for the year is also 10 microwaves. Now what happens that we need to hire a truck. So we need to pay 100 rupees so that the 10 microwaves comes to our organization. So if we are placing a one-time order of 10 microwaves at a time, we need to pay only 100 rupees. Now what happens that due to certain operational factors or financial factors, we are not able to buy all the microwaves all together. So we have limited the order size. That means at one time we are only buying 2 microwaves. So we need to place order for 5 times. Firstly we will buy 2 microwaves, then second time we will buy 2 microwaves, then third time. This way all 5 orders will complete our requirement. So what happens that every time we will call for 2 microwaves, we need to give the higher charges of 100 rupees. Now when order size has come down, the ordering cost has gone up. With every order 100 rupees is to be paid. So for 5 orders, ordering cost has gone as high as 500 rupees. So what happens that order size has come down, ordering cost has gone up. So this is what we call as an inverse relationship or a negative relationship of ordering size and ordering cost. Now students, we will learn another important factor which is essential to determine the ideal order size, and this is known as carrying cost. What do you mean by carrying cost? Carrying cost is that cost which we need to incur for maintaining the inventory at a given level. What does that mean? It means that we need to incur certain expenditure so that the inventory in our premises can be kept safe and secure. So what happens that we have ordered our microwaves. Now they have come into our organization. So whatever expenditure now I am going to incur for keeping this material in my organization are considered as carrying cost. First example of carrying cost is cost of storage space. It means the rentals which we are paying or the go down charges which we are paying to place the inventory in our organization. Second one is cost of handling materials. Third will be cost of insurance. Cost of insurance means any insurance policy or cover taken to cover the underlying value of the inventory. That shall also form part of carrying cost. Next one is cost of deterioration or obsolescence. It means that if we have ordered certain inventory altogether, now what happens that there is a technological upgradation. So the inventory has gone outdated. For example, in our case it's microwaves. So now what happens that digital microwaves would have come, or with some advanced technology microwaves have been updated. So whatever cost we have incurred due to outdated of those inventories is also forming the part of carrying cost. Next one is cost of store staff. Whosoever is taking care of stores, we are paying him certain salary or wages, so that shall also form the part of carrying cost. Now students, let us learn the relationship between order size and carrying cost. The relationship between these two are always positive. They are directly related. That means larger the order size, higher will be the carrying cost. Smaller the order size, lower will be the carrying cost. Let's learn it with our example. Now we have made a order size of 10 units. So we need to carry more units. So we need to incur more carrying cost. We need to pay more on maintenance, more on their security. And if we have ordered only small size, that means 2 units of microwaves at a time, once they are being sold off, now we need to place another one. So we will be needing less storage, less maintenance. So in that case, the carrying cost shall be lower. With this, we have learned 2 important concepts called ordering cost and carrying cost. Now students, we will learn the assumptions of EOQ. The first one is that the purchase price is constant, that is there is no discount available on purchase price. Annual demand is known and it is constant. Rate of consumption is also fixed. The lead time is fixed or 0. Lead time means that the time between placing an order and receiving an order. Ordering cost is also constant, and the last one is carrying cost is constant. Now students, we will learn various methods to ascertain economic order quantity. There are 3 methods which are suggested for finding out economic order quantity. These methods are: first, graphical method; second, tabular, or it is also known as trial and error method, and third one is formula based method. The most prevalent is formula based method. We will learn each of these methods one by one. First of all, we will learn graphical method. Under graphical method, we need to present the economic order quantity on a graph. So on x axis we will take usage, and on y axis we will take the cost. Now we need to draw 2 lines, one for ordering cost and another for carrying cost. What happens that we will draw these lines as per their relationships. So first of all, let's see what's the carrying cost slope. The carrying cost line will go upward, indicating that carrying cost increases as order size increases. So we will start from lower portion and we will draw this line like this. Now we will draw the line of ordering cost. So ordering cost line sloping downward, indicating that ordering cost decreases as order size increases. So it will come downward. Now next step is that we will draw a slope of total cost. It will be having a downward slope, like a U-shaped line will be there for total cost. Now we will see where ordering cost and carrying cost are cutting each other. At that point, we will draw a perpendicular towards the x-axis. So what happens that we will get the economic order quantity. Now next step is that we will draw a dotted line upward side towards the total cost slope, and it will indicate the total cost. So this way we can find out economic order quantity by a graph. The purpose of finding out economic order quantity is that it's that ordering quantity where the total cost should be minimum, and at EOQ quantity ordering cost and carrying cost becomes equal. Now students, we will learn another technique which is known as trial and error method. In this case, what happens that we will take up certain order sizes, and by using certain permutations and combinations, that is by trial and error, we will find out the total cost, and wherever we find that total cost is coming minimum, we will select that quantity. But this method is not as prevalent as other 2 methods. Now the last method is formula based method. This method is being used for solving the questions, and it is very important production scheduling model. Let's learn the computation of this method. Under this method, there is a formula given which is under root 2 into A into O divided by C. Now here what does A means, O means and C means? A means annual demand, O means ordering cost, and C means carrying cost. What happens that when we carry the inventory, we do not carry the inventory at such, that means we are not carrying the inventory fully throughout the year. So we are taking average inventory, because at the point we have received the inventory, it might be 10 units, then we have consumed it, it has got 5 units, then 0, then again it has gone up. So for entire period we are taking the average inventory. Now this formula has been worked using certain mathematical technique which we are escaping right now. For our purpose only the formula is relevant. Now students, we will learn the computation of economic order quantity with the help of an example. Let's see the example. The annual demand is 48,000 units. The purchase price is rupees 25 per unit. Ordering cost is 1 rupees 180 and the annual carrying cost is 12%. Now we need to compute the economic order quantity. First of all, let's understand what these data are representing. Annual demand will be substituted into the formula as A. Ordering cost is given as 180. So we will directly substitute it in the formula. Sometimes in place of ordering cost, the word setup cost is also used. Its meaning is same as ordering cost. Now carrying cost is given as 12%. So this carrying cost is generally a percentage of purchase price. So we need to find out carrying cost by multiplying this percentage to the purchase price. Purchase price is given as rupees 25. So the carrying cost will be 25 into 12%, that will be 3 rupees. Now we will use this carrying cost amount into the formula, that is in the denominator we will write 3. So numerator we are having the values as 2 into 48,000 into 180 divide by denominator is 3, then whatever we are getting the result we will take its under root. So it's coming as 2 into 48,000 into 180 divided by 3 under root. The units coming are 2400 units and that is our economic order quantity. It's also known as reorder quantity. Now what happens that we need to ascertain cost at this EOQ level. So first of all we need to find out number of orders so that we can multiply the ordering cost given as 180 rupees per order. So to ascertain number of orders there is a formula. It is total annual consumption divided by order size. Our total annual consumption is given in the question as 48,000. So 48,000 units divided by 2400, it will give us 20 orders. It means that we need to place order 20 times so that we can get 48,000 units, and each time we have to ask for 2400 units. So orders are 20 orders and the order cost per unit is known, that is rupees 180. So total ordering cost is 20 into 180 is equal to 3600. Now we need to find out carrying cost. So we know that carrying cost is to be charged on average inventory. That means whatever order we are placing, we need to carry average of it. So we will divide order size by 2 and multiplying by carrying cost. So it will be 2400, that's our EOQ units, divide by 2, that it will give us 1200 units into 3 the carrying cost which we have computed by applying the rate given to the purchase price. So it's coming as 3600. Now our ordering cost is coming as 3600 and carrying cost is also coming as 3600. So total cost at EOQ is 7200. It serves our purpose that at EOQ both ordering cost and inventory cost are equal. In some of the textbooks there is a direct formula given which is under root 2AO into C. So it will give us this total cost of 7200 directly. But we cannot bifurcate this cost into ordering and carrying cost using that formula. So we need to do this working. Now students, with this we have learned this technique. Now we will learn where it is applied and what are the limitations of EOQ. Now students, we will learn where the EOQ is applied, that is application of EOQ. It will be applied when demand for the product is constant over the year. That means we already know that we need 10 microwaves throughout the year. Second one is that each new order is delivered in full when the inventory reaches 0. That means we cannot order inventory in parts. We cannot say that we will buy the microwave in units, that first the door will come, then machinery will come. That means that entire unit will come as such. Third one is that there is a fixed cost of ordering the units irrespective of the number of units. That means whether we are buying 10 units of microwave or 2 units, the fixed hire charges which we are paying to the truck driver will remain fixed as per the distance we can assume in our example. Next one is that there is also holding or storage cost for each unit held in the inventory. Now students, we will learn what are the limitations of EOQ. First one is that annual consumption generally do not remain constant. So there is a fluctuation in the consumption. Second one is the ordering cost and carrying cost cannot be assumed to be constant. These are its limitations. With this we have learned the EOQ technique with its meaning, assumptions, applications, limitations and methods of computation. Now students, we will learn another technique of inventory control, and this is known as setting up of various inventory levels. The objective of setting up various inventory level is to avoid the situation of understocking or overstocking of the inventory. With the help of past record, we can gather the data for minimum stock, maximum usage, minimum usage, average usage, that will be the mid of minimum and maximum usage, and lead times. Now students, let's learn one by one each of these stock levels. First one is reorder level. It is that level of inventory at which purchase requisition is made for the fresh supply of material. That means it is somewhere between minimum and maximum level, and a purchase requisition is required to be raised at reorder level. Now what is the formula for reorder level? Its formula is maximum consumption into maximum lead time. Lead time means the time gap between placing an order and receiving the same. Now students, let's learn another level of inventory which is known as minimum level. Minimum level means that inventory should not be carried above this level. That means we are required to carry at least that unit of material as has been determined in minimum level. For example, there is a bakery shop. So what happens that baker needs to keep at least 4 cakes into his inventory all the time. So inventory should not go below this level. What happens if inventory goes below this level? There will be understocking. The production will get hampered. There will be the cost of stoppage of production, which will be cost of idle plant and machinery, cost of idle labor. So in order to avoid such situation where there is stoppage of production due to stock being undervalued or undercapped, we need to fix up a minimum level. Let's see what's the formula for computation of minimum level of stock. Its formula is reorder level minus normal usage into normal lead time. Now students, keep one thing in mind, the definition of minimum level. It is the minimum balance which must be maintained in hand all the times so that there is no stoppage of production. Now we will learn another level that's known as maximum level of stock. Maximum level of stock is that level of stock above which inventory should not be in hand so that we can avoid the situation of overstocking. Taking the example of baker, if the annual demand is not more than 10 cakes, so the maximum level of stock in his shop should be 10 cakes. It should not be more than that. If he carries more than 10 cakes, what will happen? He has to incur the cost of storage, cost of carrying such inventory. So, in order to avoid such storage cost, such investment cost in stock, such blockage of fund into the stock, he has to set up a maximum level. So, in one line we can say that maximum level of stock is that level above which inventory should not go at any point of time. Its formula is reorder level plus reorder quantity minus minimum consumption into minimum reorder period. Last one is danger level. Danger level means that level where urgent issues of material is made. We stop the normal issue of material. It's the level under which urgent ordering action is required. Danger level can be fixed above the minimum level or below the minimum level. If the danger level is below the minimum level, corrective action is to be taken. And if the danger level is above minimum level, it calls for preventive action. Let's see the formula for computation of danger level. It is normal consumption rate into maximum reorder period for emergency purchase. Such period generally is lower than the normal lead time. With this we have learned the various levels of stock which needs to be maintained as per the requirement of management so that we can avoid understocking and overstocking of inventory and the relevant cost which can be avoided by doing a appropriate labeling of inventory into our stock. Thank you.